In this video, we're going to focus on one-step equations with addition and subtraction only. So when you're solving these equations, you'll remember yesterday we talked about there needing to be a balance. So each side is going to be equal because they both hold the same value. If I have 2 plus x on this side and 18 on this side, I know that x is equal to 16 because 16 plus 2 is 18, and that would make the value the same. So x is equal to 16. So we did it yesterday with balances. Today we're going to do it a little differently, and this is a way most of the middle school 6th grade teachers would like for their students to solve these problems. So instead of a balance, we're going to draw a big T. So what is important, and most of you guys realized this yesterday, I could just do 18 minus 2 to find the solution of x. So what's important is whatever I do to one side, I do to the other. So your goal is to get this x all by its lonesome over here on its own. You want to push all the numbers to the other side, and when I do that, I have to take 2 off this side, and in order to keep it balanced, I take 2 off the other side. So what you were doing yesterday was just taking 2 off both sides at the same time. 2 minus 2, of course, is 0, leaving only x on this side. 18 minus 2 is 16, so x is equal to 16. And this is going to be the way that they want you to represent it, and will help you even more with the multi-step equations that we're going to get to. So what you have to realize you're doing is the inverse operation. So an inverse operation is just the opposite. When you see inverse operation, just think the opposite. So for addition, that would be subtraction. Subtraction would be addition. So this is something we're going to be using a lot throughout this section. Adding and subtracting are two opposite inverse operations, and multiplication, division is the inverse. So I always think it's the other side. So today we're going to focus on the subtraction part. Sometimes you're going to have problems written like this. And it will throw some people off that it's written that way. If you don't like the answer first, just rewrite the problem and do x minus 6 on this side and put the 24 on the right if it really makes you happy. It doesn't matter, you're going to get the same solution. But I'm going to start off drawing a T, and I've got this negative 6 or minus 6 on this side. I start talking in positive and negatives, which is mostly a 6th grade thing, but it kind of helps see the opposite of the negative is positive. So if it's a minus 6 here, I want to add 6 to make it 0 because I want to cancel the 6's out and have the x all alone. So if I add 6 here, I add 6 here, and 24 plus 6 is 30, so 30 is equal to x. In this problem here, I'm going to use a little bit larger numbers, but it doesn't matter because you're still doing the same thing. You're going to draw your T. If the 34 is in front, always remember it's a positive 34. If there's nothing in front of it, it's going to be a positive, and you're going to have to take it off this side and take it off this side in order to find the solution. So once you do that, then you can just set it up like a normal subtraction problem. 11 minus 4 is 7. 4 minus 3 is 1. So x is equal to 17. There is one type of equation that gets a little confusing, and I'm going to show you some examples. When you have something like this, 12 minus x equals 3. We can't have a negative x. So what I always have kids do is do a swapsy between the negative x and the number on the other side, switch them around. So if it's a positive 3 on this side, we're going to take off 3 and move this to this side, okay? This negative x becomes a positive x on this side. These 3's, of course, cancel out, and I have 12 minus 3 equals x. So x would be equal to 9. I'm going to show you one more. So here's another example where I have a negative x. I always look at this equal sign. When it crosses over to the other side, it's in the upside down, it's opposite land. So if I've got a negative x here, I can't have that for my answer. I want to move it over to the other side and make it a positive x. Then I'm going to take the 9 and subtract it from both sides. So I'm doing 15 minus 9. These 9's go away because 9 minus 9 is 0. 15 minus 9 is 6. My answer is 6. So be careful when there's a negative x, just rewrite the problem, move it to the other side, swap these numbers around, and just remember the opposite of a positive 3 is a negative 3. The opposite of a negative 7 or a minus 7 in your problems and where you're at right now, a negative 7 would be a positive 7. So you're just switching to the inverse operation in order to quickly solve these problems.